Hey, welcome back to Building HVAC Science. This episode today flips the script. It's episode 250 podcast since 2017. In this episode, Ginny Hebert, our new senior marketing manager, interviews Eric and I. And we just talk about a lot of things. Ginny brings up some very thoughtful questions. Eric and I give some pretty thoughtful answers. And without further ado, let's just get into that conversation.
Hey, everybody. Welcome back to the Building HVAC Science Podcast. Eric here, Bill right over there. And we have a guest interviewer today. We have Ginny Hebert with us. And Ginny, we're going to turn it over to you. Ginny is our new senior marketing manager. So, Ginny, take it away.
So for those of you who don't know me, before we jump in, I'm going to take a quick second to introduce myself. Like Eric said, my name's Ginny. I'm the marketing manager at TruTech Tools. And a little bit of background, I didn't actually come from the trades originally, but I will say the industry definitely has a way of pulling you in. Everybody that I've met so far care a lot about people in the industry and doing things the right way, not just the fast way, and about comfort, performance, and really the bigger picture behind the tools and the equipments that you use. And that's what makes this podcast so special. So for the 250th episode, it felt right to flip the script and put the host in the guest seats. So should we get started?
Yeah.
All right. This is going to be fun and interesting and backwards feeling.
So episode 250 is a really big deal. If you had to think back to one episode, like episode 1, and where we are now, is there anything that you didn't know about buildings, the industry, or even yourself?
I'm going to have to let Bill take that one because I didn't join until much later in this. Bill's the guy that's been around for the whole 250.
Yeah. So back in 2017, Brian Orr talked me into doing this and helped me get started. And first, I think what I learned a lot about was how to create a comfortable environment through a lot of the speakers or guests that we had on the show. Some techniques, some measurements, some things that I overlooked. I'll just say Robert Bean, he's been on the show a couple times, mean radiant temperature and just overall like human comfort. And I'll say that there's a lot of value in those conversations that I use to build the house that I live in.
Super cool. Is there one belief or takeaway from the show that's since changed your mind on?
This might not be totally on point with your question, but I think I've heard enough or seen a lot of conversations and comments about it being impactful for individuals that I wouldn't have thought. At first, I was doing it to fulfill my curiosity in a number of different topics, but the feedback that I've received is this, in part, this helps people stay engaged with the industry, learn new things, and be attracted to our thesis of doing better for people.
I would say there's possibly a few things that I've changed views on after talking to guests, more just expanding my views, I think, and the things that I do know. I wouldn't say a complete 180 on anything that I've had. It's just expanded and modified some different things as I've gone through, which is how I approach the industry and my time in the comfort industry as a whole is I start out with something and I expand and change and grow with anything that I learn, really.
And maybe this is a question for Elk, but Bill, feel free to also give your take. Is there a simple concept that keeps coming up again and again, but is really at the root of comfort for our homes?
I think really one of the deepest concepts that people can learn for any home comfort, building comfort, whatever that is, indoor comfort, is really the transfer of heat and how heat transfers through materials, how heat transfers between the materials and the humans that occupy those materials and occupy on the inside of that. I think that's really one of the biggest concepts that is, I'll say, not understood deeply enough by the technicians that are charged with going in and keeping the buildings comfortable and keeping the occupants comfortable and healthy.
Something I realized that's part of that expands on just a little bit is the retention of heat. in materials and humidity in materials. That's something I never really appreciated that much, and how they're often like elements not thought of. You're just thinking about, or there's just this air that we got to take care of. But it's the materials too and the people that are all part of this whole comfort equation.
Do you think it's the lack of communication between building the house, the contractor, to the tech who comes to service it? Do you think that plays a role in the comfort in our homes because of the materials used?
I really think it just comes back to our mindset as technicians. We really want to dive into nitty-gritty things, and sometimes we want to dive into flashy things, and we really forget to go through the basics well a lot of times. And supplying good comfort to people comes back to looking at the building the house as a system, and the mechanical systems, the HVAC systems we put into that larger system are just a single component. And I think it just comes from our mindset of, hey, I need to go fix this piece of equipment, or I need to fix whatever this thing is, rather than stepping back and being able to build that whole system into our heads or into our minds and visualize that. And that is, I think, just been a trickle-down effect over the years, where a lot of people haven't really taught that whole building as a system, structure as a system, house as a system technique.
I'd like to add to that with what you're describing is fantastic. It's a thoughtful process that takes time, both time to learn, time to experience, because it doesn't always go the same way, and then time to execute. But that's like on one side of the table. The other side of the table is it takes too much time. There's either time pressure or financial pressure. Tear it out and replace it, or just do that. Just iterate something that worked maybe before.
It's a very interesting point. And it's definitely one to keep in mind, because there is always, I'll say, I've never had a job where there wasn't either time or financial pressure in some way going out to work on a job. And that is always a thought process that a technician has to go through no matter what they're doing. So very wise and good insight there. I'll say it took me as a technician a long time to learn these things in the field. And even my early instructors, I don't think had a really good grasp of that. And I think that as the industry is progressing, and this was a piece that Bill and I really talked about when I joined TruTech, was both of us had this shared goal of connecting multiple parts of the industry together so that they really understood each other. And I don't think that the industries have really thought about the whole system in general. So it takes some time to grow that.
But I'll say over my career, that is rapidly accelerating. Even though it might look small from your perspective, it's moving fast.
It is, yes.
On that same token, what else is moving fast in the industry as far as improvements and enhancements? Are there any other concepts that you feel like have really improved?
I'll add, I think the improvement in computing horsepower, both what you can have in your hand on a job site or on your desk in your office, and the use of AI to help quickly move through a topic, either learning a topic or digesting information. So like specific things like using iPads with LiDAR in them to do load calculations, to scan a space, and to quickly build a model so that you can correctly size the heating or cooling equipment. And I think that's going to continue to iterate into more varieties and versions of doing better and better, putting tools in the hands to do better work. So computing horsepower.
Yeah, I would expand on the computing horsepower to be the interconnectedness of tools. When I started in the trade, everything we had, whether it was whatever readout it was to us, we had to write down literally every single reading. And as a technician, we were challenged with writing all this down or trying to sometimes memorize it, look at it in a way that we could memorize changes in our mind or visualize simultaneous changes in our mind or try to write down information. And with the connected tools and the differing displays that we have now, being able to bring multiple readings onto one screen and maybe record it or data log it or graph it or have that software that we're using on a smart device or whatever that might be help to process all that information is a massive change in our workspace, whether it be testing buildings, whether it be evaluating an HVAC system. All of that has had these improvements to it to where we can get that information, get it processed faster, get it processed much more accurately in a very timely fashion, which enables us as technicians to make better decisions and communicate to customers better, communicate to those end users better about potential problems and potential solutions.
Speaking of potential solutions, I actually just learned that my house has a heat pump.
Oh,
So I'm wondering, what is the biggest misunderstanding that still exists about heat pumps, and where do you feel that they actually can be beneficial?
I'll go first. Understanding that the output temperature is lower than a combustion-fired furnace. And because of that, there's actually like less energy content that's going to come out over a period of time. So expect them to run a longer period of time. And especially if you have something that's variable speed, it may run at low level almost continuously. And then when it gets near its design temperature, it may run continuously at the highest output, both of which are good things. It's operating in the range that it's been intended to operate. So I think the on-off nature of single-stage equipment for consumers is something that heat pumps may befuddle them, especially variable speed heat pumps. What do you think yours is?
Considered me befuddled. We just had a really cold night the other night, and my heat pump ran continuously, and I was panicking, thinking that we were using too much energy or there was something wrong. And so immediately I take to the internet to tell me. And it turns out everything was working right.
Good.
I think you just alluded to a big thing there, which is expectations, is not only end user expectations. A challenge that the industry, from an industry technician point of view, is not only knowing how to set the controls up, but wiring those controls up sometimes, and then communicating to an end user how it's going to operate. And for your example, Ginny, you just bought a house and you've never been in this house before. So you have no idea what to expect about how this is supposed to operate. And it's hard for a technician to communicate that to you. Now, you're going to go take to the internet. You may phone a friend. You may call a colleague and say, hey, what's going on here? And you might learn a lot there too. But there's different strategies to keep good comfort with regards to setting up the controls and selecting the equipment and configuring the equipment. Whereas our gas furnaces were typically very simple to hook up, very simple to wire up. They were a very repeatable process, where heat pumps aren't always the same if you switch brands or you switch sizes or you switch houses. They're a little bit more complex to make those connections with the control systems. And really, there's a little bit more that a homeowner needs to know in order to operate them. So they're not quite as plug and play as just a gas furnace that turned on and off and just ran the heat all the time. So with that heat pump, you're typically going to have multiple sources of heat, especially in the colder environments that we live in.
And we'll save you another internet search. When you see steam coming off it in the winter, it's not burning up.
Good to know.
It's going through defrost mode.
Yeah.
So don't call 911. Got it.
No.
Okay, that's good to know. We actually do have a second source of heat in my house. It's a real fireplace. And that's actually what I grew up with as my main source of heat, is a wood fireplace in the basement. So constant heat is something that I grew up used to. And then when we did switch to the furnace, the on and off, my dad would always talk about the length of time it was on. So hearing something run continuously was like a huge red flag to me, because I didn't know what I didn't know. Turns out it was a good thing, but I think we're going to have to go back to what my dad would call as Camp Concord and chop up some wood for that fireplace.
You're going to get to learn how it is to live with a heat pump, and you're probably going to get to learn some differences between like a gas furnace and that heat pump. You do happen to have a couple of really good resources sitting right here in front of you for that knowledge, though. So,
yeah, but Eric, she might be out there searching like 11:30, 12 p.m., midnight when she's got like the end of the day and you're thinking about these things. So
Yeah. When the panic sets in at about 11:30 p.m., I'm not going to call you, but I will ask you the next day.
Okay.
I mean, I'll take that call. I've taken those calls for pretty much most of my career. And if my phone rings, I'm going to take that call.
You're a good man.
What is one of the most common problems that's identified as an equipment problem that really is a system or building problem?
Ooh, I'll say you kind of alluded there to runtime on an equipment. When we put in HVAC equipment into a house or heating or cooling equipment, I'll say not just that, but we're not really talking about ventilation there at that point, but heating or air conditioning equipment, the space is constantly either losing or gaining heat unless there's an equilibrium with outside temperature. And we can go two ways with this. We have to understand how much heat that space is going to gain or lose at a specific, what we call design temperature. And then we have to match equipment to that. And if the wrong things are put into that calculation, or if there's something that's different about that building, maybe say it wasn't insulated in one room or part of a room wasn't insulated. Maybe somebody didn't put insulation in the walls or the ceiling of a room, and that room is actually really uncomfortable. Well, a lot of people will say, hey, I just need more heat in this room, or I need more cooling in this room. And they don't step back to realize it's not an equipment problem. It's a building problem, but they can't see that in behind the walls without either tearing things out, physically getting in there to look at that, or maybe using some extra diagnostic equipment and tools to figure out what that deeper problem is.
And it's possible that the original design did not peel back the layers, so to speak, to know what was going on. Typically, and I had this one of my houses, was the frog, the family room over the garage, and the knee walls in that family room, and also the floor, and how they were connected to the cold garage space beneath them. There was a great image still in my head. This goes back to a campaign, I believe it was Knauf Insulation had a number of years ago, was bleeding red. And it's like the thermal image of watching your house bleed red, bleed heat in the wintertime. And I think one of the things, maybe even, I'd say a lot of contractors, but most of the consumers don't realize it's the movement of air versus the layers of insulation that make a huge difference, because that's where the heat gets transferred. So this air leakage idea, blower door testing, air changes per hour, that's a system input should be a system input to the design of your equipment. Oftentimes it's overlooked, neglected, or maybe just misestimated.
And that goes back to Eric's first 3 rules of insulating. And those first 3 rules of insulating are air seal, and air seal. Because if you don't air seal the insulation, most insulation is not going to do any good, especially if it's fiberglass, which is the most common insulation out there.
So what can homeowners listening to this or techs suggest that are listening to this today that people can do to air seal? What can we control and step up and try to make our homes a little bit more comfortable?
I hesitate to suggest anything specific without knowing something, because that can get expensive. There's a lot of recommendations out there about air sealing windows and things like that, because those are really easy to access and most homeowners can do that. And if you have really, really bad windows, that might not be a bad idea. Put a layer of plastic over them. If there's wind blowing through them, like if the wind's blowing and you can walk up and feel that wind blowing through, or if you're a tech and you've got a handheld smoke generator and you can take that smoke generator up there and you can see that wind blowing through, a plastic sheet on the inside fastened tight may be a really big help. But because of the way stack effect and hot air and cold air interact in buildings, a lot of times the windows aren't going to be our biggest leakage point. Despite being really easy to access, they may not help quite as much as we think if they don't have those immediate air leakage through them. So you really should look at doing some testing with a tool like a blower door to do a house leakage test, and pair that up with some kind of a handheld smoke generator, possibly a thermal camera, to visualize where those leaks are. Now that thermal cameras, of course, have limitations because you have to have a temperature differential between indoors and outdoors. We have a good friend that learned that the hard way, don't we, Bill?
Mm-hmm.
He and his dad went and looked at a house, and it was the same temperature indoors and out, and they put a thermal camera on it. And man, it looked great.
There's no transfer of heat because there's no driving force.
Yeah, so there's no driving force, but across that assembly of the wall or the roof and whatever they were looking at. So it can look really great, but that's a false sense of security there.
And we've had a couple guests on the podcast who can help techs and consumers understand this and build up the thinking here. One is Nate Adams, and he has a website, Nate the House Whisperer, and a book called Home Comfort Book that actually TruTech resells too. But you can get a lot of free information off Nate the House Whisperer. And Eric George is the other one, more recent guest back in April, learnhomecomfort.com. He's got a number of videos where he does a lot of training, and he does some video podcasting too, has some guests on. So there's a couple great sources to hear people talking about the basics of our discussion here.
And let's not forget about Corbett too, Corbett Lunsford.
Oh, yeah.
Homediagnosis.tv.
Yeah, that's a good one.
All three good resources for knowledge. But you can go through and do a lot of work at air sealing and not make a big difference if you don't know where that air is leaking through. You can spend a lot of time for very little effort. And doing a little bit of testing on the head end can educate you a lot.
And for consumers, Home Boost. She was also a guest on the podcast, Selena Tabakawala. That's a product where you actually can borrow a thermal imager and send the data to an energy expert to review what's going on in your house. And that's the kind of thing that Eric's talking about, is it needs some expert eyes to look at before you begin going full bore with fixes.
Cool. So unless there's a draft or a crack in your window, maybe take a pause.
Yeah, right. If you can see light, put it that way, you can see outdoor light coming in the daytime, yeah, you've got a hole.
Not through the panes of glass.
Yeah, right. Other than through glass.
Yeah.
And if you've got something like a single pane window in there, that's definitely not going to be a good thermal break. If you've got a good double pane window and it still has the gas in it, it's fairly tight.
Or if you have sensitive ears, and I've done this in my daughter's house that's built in 1960, she had some sash windows that didn't latch correctly, and there was a gap. I could hear the outside in one room and not hear the outside in the other room because she lives near a street. So if you can hear outdoor noise, there's a pathway for the air getting in.
That's a really good technique, actually.
It's acoustic testing, right?
It is. And especially if you can make comparators and things like that. I wonder, you could probably use, there's a couple iPhone tools out there or phone tools that have decibel meters on them. And using that in that area, there's one put out by NIOSH that is very accurate.
Yep.
But realistically, even if it's not accurate, you would use that as a comparator tool because you're comparing it in two similar spots. Like Bill said, if you got one room or another room, make that comparison there to outside. Make sure you have similar noise levels indoors when you're doing this, and you're a similar distance from where you suspect the leak might be. And if you have higher levels in one space and you've got a similar noise level outdoors when you're testing between the two spaces, probably got air leaks in there somewhere because sound loves to travel through paths of air.
Good to know. If, Bill, since you've been on every episode.
Almost.
You've been around since day one. With all the guests that you've had on the podcast, if you could wave a magic wand and make one practice standard across the industry, what would it be and why?
Spend time thinking about the problem. And that thinking might include thinking while learning, thinking while experiencing, and thinking while practicing. And I do throw that experience element in there because we're not all born with the knowledge it takes to do this. And actual experience yourself makes the biggest difference. I think it imprints differently.
Nice.
Thanks.
With the evolution of 250 episodes, do you feel like your role and your responsibility has changed at all?
The role, yes. I'd like to try to defer more to Eric. And actually, he's covered in a pinch where I couldn't be on and we had scheduled, and he's just done the whole thing with aplomb, with perfect precision. But my responsibility, no. we both get requests from people and we scrutinize them. We share, is this really appropriate? Not that the person is inappropriate, but is the topic fitting our theme? I will add one anecdote here. Somebody sent me an email and said, would you like to cover, it was like an energy drink, something like that, because technicians need to stay energized at work. And I'm like, you're pulling it. I said, that topic does not fit the thesis for our show. And that person wrote back, oh, the thesis. So I don't use the thesis anymore. It's like the subject matter.
Okay. What do you think, this can go to either one of you, if someone is listening to this in 10 years from now, what do you hope they take away?
Wow, 10 years. I would hope that the industry around us has continued to grow. The instrumentation and the tools that we use have continued to grow. The practices of the people in those industries have continued to grow and move forward in a positive manner. And I would hope that people in 10 years can look back at this and say, wow, we've come a long way, and that maybe these two guys sitting behind their microphones over here were a small part of helping to move that forward.
I'll echo that, just a few different words, but fringe ideas, topics, techniques that we talk about, that a lot of them become normal every day.
Can you give me an example?
Do you test every system you touch in some way or another, heating or cooling system? Another example is, we're on the fringe of this now, is a way of assessing the indoor air quality, which is a health parameter on all the work that you do, either coming into it or what you do to a space. Anything from you, Eric?
I would hope that maybe we get better at offering that larger testing on the building and offer an evaluation. I hope that maybe in 10 years' time, we can have a really good method of using some kind of an instrument to more closely assess people's comfort in a space and predict that comfort. If people are having comfort problems, we can assess the space to their uncomfort, and we can then predict that they'll have a comfortable space a little bit closer without taking quite so many guesses. Do I know what that looks like right now? No, I got some concepts, but I also think a lot of other people out there are potentially working on that right now.
So with 250 episodes, what is one thing you want to thank your listeners for? I know that you just said we had over 200,000 downloads of the show. Is that correct?
Yeah, 235,000.
Wow, incredible. What would you like to thank those 235,000 people for?
I would like to thank them for coming back to listen to more than one episode, and for accommodating where Eric's and my brains go. Because it's not often linear.
It does tend to dive down some holes once in a while. I'd like to say thank you to everybody just for even tuning in once. If there's one show that helps somebody out there to take the next step in their career and their path in learning, I am just so happy they stopped by. And maybe if they liked it, maybe they'll come back and pick something else up. One thing we do have on this show that I really like is we have a wide variety of topics we touch on. It's not always the same thing. And I think that's good for both of our brains because, as Bill said, they don't always move linearly. Sometimes they hop from rabbit hole to rabbit hole. And that really keeps it interesting for both of us and hopefully keeps it interesting for our listeners as well.
And not quite the same question you asked, but I think asking people to share their backstory and sometimes just their whole story is a whole episode. I really thank those guests for coming on and sharing, being open. And I really hope that those words get somebody over some kind of hurdle, whether it's a career hurdle, whether it's problems they encounter on the job, that it just helps them move through things that we've contributed to our community.
This is the final question for both of you. So I'd like if you guys could both finish this sentence. Good building systems start with blank.
A plan.
A thoughtful process.
Kind of one and the same. Awesome.
Yeah. It's going to come down to where you can visualize the whole process. And you're going to miss some stuff in there. So part of that process has got to be a little bit of flexibility to say, hey, okay, we got to change something because it's a really, really complex system.
Don't neglect the quality assurance or having somebody work with you, check your work, or double checking your own work, especially for the results, parameters, the things you're trying to achieve.
Yeah. Goals are a good thing to have to set up that plan and that thoughtful process.
All right. Well, thank you so much for letting me interview you.
And thank you for doing it. And thank you for coming on this TruTech journey with us. We appreciate you.
Yeah, happy to be here.
Thanks, Ginny.
Great. Thanks. Thanks for listening into this 250th episode of the Building HVAC Science Podcast, episode entitled Beyond the Equipment, Reflections on 250 Episodes of HVAC and Building Science with Eric and Bill. Well, if you stuck around this long, I'm going to plug you with a couple other little thoughts. If you have any questions or want to suggest a topic, reach out to marketing@trutechtools.com, TruTechTools.com. And you can find us, our podcast, on Facebook by typing Building HVAC Science into the search bar. You can also find TruTech Tools at our website, TruTechTools.com. On the Building HVAC Science Podcast, a production of TruTech Tools Limited. And full disclosure, I'm the owner of TruTech. The opinions expressed are those of my guests, my co-host, or myself, depending on who's speaking, of course, and also our guest host, Ginny, in this case. If you're in the market for any tools or test instruments mentioned in the podcast, look at what TruTechTools.com has to offer. And you can use the offer code, secret offer code, HVACBS for a nice discount. I want to thank you for listening to and following us on Building HVAC Science. Got to give a shout out or a tribute to other trade-related resources and influencers that are out there, including HVAC Our School. Thank you, Brian. HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVAC Our Videos, the HVAC Grapevine, HomeDiagnosis.tv, AC Service Tech, Measure Quick, and HVA Chicks. Appreciate you all. You helped play a role, I'm sure, in what we've done here with this podcast, and we look forward to more interactions in the future. Take care, everyone, and looking forward to a great 2026. Bye.